This video is about review for logic. 1a. Consider the following statements. A is divisible by 9. Q. B is divisible by 9. S. The product of A and B is divisible by 9. Write down this statement in words. First of all, let's look at the meaning of each symbol. This symbol means if and only if. This symbol means and. Therefore, we can write down like this. The product of A and B is divisible by 9 if and only if both A and B are divisible by 9. Let's go to 1b. Complete the following truth table. We have P, Q, S, P and Q. The keywords will be both must be true. To be true, both must be true. Therefore, you will get this is true, true. Rest of them will be false. This symbol means if and only if. To be true must be the same. So you need to check these two columns, this and this. Must be the same, then this is a true. True. This is a true. 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 Rest of them will be a false because it's not the same. 1c. Justify why this is neither a tautology nor a contradiction. Because the last column contains both true and false values. If the column only contains true values, that's a tautology. If it contains only false values, will be a contradiction. Now let's go to 2a. Consider the following propositions. P, the baby cries. Q, the baby is happy. R, the baby wants to play. Write down in words this statement. First of all, you have to check each symbol's meaning. This one means and. This means if, then. This symbol means not, negation. Therefore, if the baby is happy and wants to play, then the baby doesn't cry. To be complete the following truth table. Q and R. And. To be true, both must be true. The keyword is both. Therefore, you look at these two columns. You have true. This is a true. Rest of them will be a false. This symbol means if, then. Keywords is all true except true, false. You need to look at these two columns. But make sure it's this way. From Q and R implies not P. In other words, you have to say this way. It's a true, false will be false. Rest of them will be true. So this is a false. That's the only false. The rest of them will be true. For 2C, state whether this is a tautology, contradiction, or neither. Look at the last column since it contains both true and false values. So this will be neither. Let's go to 3A. Consider these three propositions in which x is a natural number. That means 1, 2, 3, 4. Keep going. Write down in symbolic form the compound proposition. If x is a factor of 60, then x is a multiple of 5, or x is not a multiple of 4. For P, x is a factor of 60, Q, x a multiple of 4, R, x is not multiple of 5. Let's check this compound proposition. We need keywords. If, then. That means this symbol. We have or. That means this symbol. Not means this symbol. Therefore, x is not a factor of 60. That's P. Implies x is a multiple of 5. That means R. Or not Q. So we can write down P implies R or not Q. Remember, you have to put the parentheses. No parentheses. At most, you can get the 2 marks. Therefore, for symbolic form, if you have more than one symbols, you have to consider parentheses. Let's go to number 3B. Write down in words the compound proposition, this one. First of all, you need to know the meaning of symbol. This will be not. This is and. Or, but, not both. When you see or, but not both, you can use either. Or, but, not both. So we can write down x is not multiple of 5, and either x is a factor of 60, or x is a multiple of 4, but not both. For 3C, copy the following truth table and complete the last 3 columns. This means not. Get the opposite of R. So you have false, 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 false. Then here's true, 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 true. This symbol means or, but, not both. Keywords will be exactly 1. To be true, exactly 1 must be true. Therefore, I look at this PQ, these 2 columns. This will be true, 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 true. Rest of them will be false. Then you need to look at these 2 columns. And means both must be true. To be true, both must be true. So we have, this is a true. Here's a true. Rest of them will be a false. (3D). State why the compound proposition this is not a logical contradiction. Logical contradiction means that column only contains false value in the truth table. Therefore, the reason will be the last column doesn't only contain false values, it also contains true values. For 3E, a row from the truth table from part C is given below. Write down one value of X that satisfies these truth values. Not R will be true. P or Q, but not both. That exactly one will be true. Then for this end, both true must be true. Therefore, here's true. For A, consider the following propositions. P, the lesson is cancelled. Q, the teacher is absent. R, the students are in the library. Write in words the compound proposition this. First of all, let's check the meaning of each symbol. This means if, then. This means and. So we have if the teacher is absent, then the lesson is cancelled and the students are in the library. When you write down the compound proposition in words, you have to use these keywords, like here, if, then, and here is and. For B, complete the following truth table. Not R means opposite of R. So we have false. Here's a false. True, true. If, then. The keywords will be all true, except true, false. Therefore, from Q to not R, this way. We check true, false. This will be false. True, false. We don't have any. So we have true, true, true. For C, hence, justify why this is not a tautology. Tautology means for that column, you have to have all true value in the truth table. Not all the entries in the last column are true. Let's go to 5A. P, X is a multiple of 12. Q, X is a multiple of 6. Write down in words, not P. X is not a multiple of 12. 5B, write down in symbolic form of a compound statement. R, if X is a multiple of 12, then X is a multiple of 6. If, then. That's this symbol. So we have P implies Q. That will be R. 5C. Consider the compound statement as if X is a multiple of 6, then X is a multiple of 12. Identify whether S is the inverse or converse or contrapositive of R. You have to remember the difference between converse and inverse. Inverse means negation. So we have not P implies not Q. Converse, like a conversation, we go back forth. That's why you switch if and then. So we get the Q implies P. From this, if X is a multiple of 6, that's this switch. Therefore, it will be converse. 5D. Consider the compound statement as if x is a multiple of 6, then x is a multiple of 12. Determine the validity of S. Justify your decision. It's false or not valid. Because 18 is a multiple of 6, but 18 is not a multiple of 12. Let's go to 6A. Consider the propositions R, P, and Q. Complete the following truth table. R and P, keywords will be both. So we have true, true. Rest of them will be false. For this, that's all. Keywords will be at least. To be true, at least one must be true. Therefore, you need to check this column and this column. True, 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 true. Rest will be false. Then we do not to this column. We have false, 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 false. Here's a false. Then this will be true, true, true. Last column. This is and. Keywords to be true. Both must be true. So you need to check this column and Q. These two columns. Both true will be true. This is true. 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 Rest of them will be false. For 6B, determine whether the compound proposition this is a tautology, a contradiction, or neither. We check these two columns. They are exactly same. So, to be true for this equivalence symbol, exactly the same. Therefore, this will be tautology. Give a reason. You can draw the truth table. Then show the value in the truth table all true. Another reason you can give, you will see these two, they have the same value in the truth table. Now let's go to 7A. Two propositions P and Q are defined as follows. P, Eva is on a diet. Q, Eva is losing weight. Write down the following statement in words. This symbol means if, then. So when you write down the statement in words, you have to use this phrase. If Eva is losing weight, then Eva is on a diet. 7B, write down in words the contrapositive statement of Q implies P. Contrapositive means you do converse and inverse together. Converse means you need to switch. And inverse, this N stands for negation. Therefore, if Eva is not on a diet, then Eva is not losing weight. This will be the contrapositive statement of Q implies P. For 7C, determine whether your statement in Part A is logically equivalent to your statement in Part B. Justify your answer. You need to draw the truth table to justify. Let's draw the truth table. You have PQ. Q implies the P keywords will be all true except true, false. Q implies P, you have to see this way. So we're looking for true, false. This will be false. Rest of them will be true. Not Q, you have to check this column. Opposite of Q, this will be false, false. Then you have true, true. Not P, you have to check this. So you have false, false, true, true. Not P implies not Q. You have to see this way. Still all true except true, false. Check these two column and then it's from not P to not Q. Looking for true, false. So we get this is a false. Rest of them will be true. In this way, we justified our answers, which means these two, Part A and Part B, they are logically equivalent to each other because we have exactly same value in the truth table. Let's go to 8A. Consider the following propositions. P. Students stay up late. Q. Students fall asleep in class. Write the following compound proposition in symbolic form. If students do not stay up late, then they will not fall asleep in class. The keywords is if, then. Then you have this not. So we have not P implies not Q. 8B, complete the truth table. Not Q, opposite this Q. So we have false. Here is a false. True, true. This symbol or at least one is true. Therefore, you will get these two column we check. This will be true, true, true. So we have false here. This one means not. So check this. Get the opposite for that. It will be false, false, false. This is a true. 8C, write down a reason why the statement this is not a contradiction. Contradiction means in the truth table, all values will be false. But when you check the last column, not all entries in the last column are false value. That will be the reason. Now let's go to 9A. Consider the propositions P and Q. P, I take swimming lessons. Q, I can swim 50 meters. Complete the truth table below. Not Q means opposite of Q. So you have false, false. Here we have true, true. This means or. Keywords will be to be true, at least one must be true. Therefore, check these two columns. At least one is true. True, true, true. This will be false. 9b. Write the following compound proposition in symbolic form. I cannot swim 50 meters and I take swimming lessons. Keywords is and not. I cannot swim 50 meters. That means not Q. And will be this symbol. Take swimming lessons. That's P. Look at the 9C. Write the following compound proposition in words. Let's check the meaning of the symbols. This one means if, then. This will be not. There was a mistake for 9C. This will be P. So we have if I can swim 50 meters, then I don't take swimming lessons.